So in this video we're going to find the inverse Laplace transform of this function here, s plus 1 squared plus 2, which looks like that's got a completed square on the top, and in the denominator we've got s to the 4 plus 2s cubed minus s squared minus 2s. Now, as always, I break these fractions down, so I'll get it as f of s equals p of s over q of s. Now I can see that the order of this polynomial on the top and the polynomial at the bottom, there is two different. So this has gone up to squared, this goes up to the power of 4. So therefore the limit of f of s as s approaches infinity is 0. So partial fraction decomposition is one of the ways we can go with this. So my p of s, that equals s plus 1 squared plus 2, and q of s will be my denominator. That equals s to the 4 plus 2s cubed minus s squared minus 2s. Now we want to try and break this down into some kind of factors, and as this is a quartic, it's going to be quite a challenge. So I can see s is in every term, so let's do that. So we can take an s out to give us s cubed plus 2s squared minus s minus 2. Okay, now let's do something with this. Now we've got s cubed and 2s squared and minus s and minus 2. So there's a factor of 2 between the first two and the last two. So some sort of grouping will work quite nicely here. So we've now got s. Now if we group these ones into s squared, take s squared out of that, and then we'll be left with s plus 2. That will take care of that. Now this one we've got minus and s minus 2. But if we put a bracket around these, then we're looking at minus s, and then this minus will become a plus, because we're going to have a minus be distributed inside here as well. So therefore we could have a 1 here. So we'd have minus 1 s plus 2. And that would be, an s plus 2 would be common amongst the two. So then we could have s times s plus 2. That would be these ones. And then we've got an s squared minus 1. Now, s and s plus 2, that is all good. S squared minus 1, we can now factor this directly. So now we've got s plus 2, s squared minus 1, I could write as s squared minus 1 squared, still the same, difference of 2 squares. So now I could write as s plus 1, s minus 1. Okay, so now my f of s, that equals s plus 1 squared plus 2. Now my denominator becomes this, s plus 2, s plus 1, and s minus 1. So now we're ready for partial fraction decomposition. Now if you check the link below, you'll see the video where we went through all of this process in detail and got a result for this partial fraction decomposition. So I don't want to do that in this video because I want to concentrate on the inverse Laplace transform of this function. But the result we got was, this then translates to minus 3 over 2s minus 1 over 2s plus 2. And then we add 1 over s plus 1 and 1 over s minus 1. Okay, so now we can take this off the board and we can continue to concentrate on the inverse Laplace transform. Okay, so now this is what we want to find the inverse Laplace of. So now we rewrite this now with our terminology. Inverse Laplace of f, that equals the inverse Laplace. So I can put an equal sign here and an inverse Laplace sign of all of this. Okay, so now what I can do is, I've got 4 terms in there, I could break them up individually and do inverse Laplace of each term. So now we've got the inverse Laplace of minus 3 over 2s. Got a minus sign here. Now 1 over 2s plus 2. So inverse Laplace 1 over 2s plus 2. This one here, 1 over s plus 1. We've got a positive sign. So inverse Laplace 1s plus 1. And very similar with this one, except an s minus 1 in the denominator. Also a positive sign. Okay. Now this one here, I've got a minus sign here. I can bring that out, but I could also bring the minus 3 over 2 out. So let's do that with this one. So now I've got minus 3 over 2. Inverse Laplace of 1 over s is all we've got left over now with that. Same here, I can take the half out. So I've got minus 1/2 inverse Laplace 1 over s plus 2. And then these two terms I just bring down as they are. So inverse Laplace 1 over s plus 1 and inverse Laplace 1 over s minus 1. Okay, so now I've got all these terms here now in a format we can use our chart of inverse Laplace functions. Now this one here, so the inverse Laplace of a over s, that just leads me to my result being just a, where a is a constant. Now these ones here are of a very similar format. Now my inverse Laplace of 1 over s minus a, that just gives me e to the a. And if there's a constant which we can multiply by, which we can put here, I will just get a constant in front of my result. And likewise, my constant could also be in here, in which case I could put my constant there if I wish to. That would also give me the same result. So looking at this one, I've just got my a here, which is for 1 over s. Same with this situation here. I could take my a out, change that to a 1. My result will then still be a. So this is the situation I've got here. So this one here will now just be minus 3 over 2. So that takes care of this one. This one here I've got a constant, which is minus 1/2. So I could write that as minus 1/2. And 1 over s plus 2, here my a is minus 2. So a equals minus 2. So now, don't forget the constant, the variable t, ce to the at. So now I've got a equals minus 2. So now I've got ce to the a2. So now I've got 1/2 minus e to the minus 2t. So that takes care of that one. This one I've got a equals minus 1. So now here I have got plus e to the minus t. No constant with that one. And this one here, my a is just 1. So then I've got add e to the t. Okay, so now let's just simplify this off a little bit, just put it all a little bit more neater. So minus signs I like to put at the back and a positive sign at the front. So now I'll write this as e to the t plus e to the minus t minus 1/2 e to the minus 2t minus 3 over 2. And I'm going to declare that as my result. Okay,